In this lesson, we're going to be learning about doing lines of best fit. So let's start by looking at the learning goals. By the end of this lesson, you should be able to 1. Define a scatter plot and understand its purpose. 2. Define an outlier. 3. Draw a line of best fit through some data. 4. Determine whether a relationship is positive, negative, or neither. 5. Define interpolation and extrapolation. And 6, determine the equation of your line of best fit. So quite a lot of lesson expectations for today. So let's get started. So first thing that we were expected to do was define a scatter plot and understand its purpose. So let's read the first paragraph here. A scatter plot is a graph of a set of data points, x, y. Scatter plots are drawn to see if there is a relationship or a correlation that exists between two variables x and y. The independent variable is graphed on the horizontal axis right here, and the dependent variable is graphed on the vertical axis. So, what is the definition of a scatter plot? It's a set of data points to determine if a relationship exists between the two variables. So let's take a look at the first example that we're given here. We have height, which is on the y-axis, that's your dependent variable, versus age, your independent variable. And we're looking at the relationship between height and age. So, as age increases, what could we say happens to height? Is there a relationship between height and age? Well, as age increases, height tends to increase as well. So we can see that there is a relationship there, which is determined by the use of a scatter plot. Next, the next expectation we had was to define an outlier. So an outlier is a point or points that are separated from the main body of the data. They don't follow the same trend as the rest of the points. In this graph, we did have an outlier right here. And we tend to include outliers when we see them in experiments, and we have to report them because they're part of our data set. There are some conditions in which you can discard an outlier, like for example, if you know you made a mistake with that data point and you can account for the mistake, then sometimes you can discard that data point. However, it is good practice to always include your outliers when you are plotting a scatter plot. And the definition of an outlier is, again, a point that tends to not follow the trend. The relationship of a graph is according to the direction of the slope of the graph. So that brings us to this right here. Determine whether a relationship is positive, negative, or neither. We're just going to skip the draw line of best fit for now, but determine a relationship is positive, negative, or neither. So if we take a look at this right here, if we have some data points and they tend to follow this trend, we would say if y tends to increase as x increases, so as x gets larger, y tends to get larger as well, then the data has a positive relationship. All right? So if you can draw a line of best fit that goes through these points and it looks like this, that is considered a positive relationship, and that is because the slope of this line is positive. If y tends to decrease as x increases, so as x gets bigger and bigger, y gets smaller and smaller, and we can draw, for example, say like a line of best fit as such, then we say that the data has a negative relationship. So as x increases and y decreases, that's a negative relationship. And that's because the slope of the line of best fit is negative. Finally, if the points show no obvious pattern, and then there is no relationship. So for example, here in our scatter plot, these data points do not follow a trend that is observable from these data points. So we would say no relationship here and no line, right? No linear relationship between that. Okay. If there is a trend, so we're moving on over here. If there's a trend, we can draw a line of best fit to make predictions. So that's what I did here. The line of best fit should go through as many points as possible, while at the same time have approximately the same number of points above and below the line of best fit. So when I drew this line of best fit, I just kind of eyeballed, what is a line that, seems to have the same number of points above it and below it approximately, and going through as many points as possible. That's how you draw a line of best fit. And it's really important to note as well that the line of best fit does not have to go through the origin. And we see that over here. It's not going through the origin here. It's not going through the origin here. It can go through the origin, but it does not have to. Okay, so that is how to, if we go back to our lesson expectations, draw a line of best fit through data. Okay, it goes through as many points as possible and has the same number of points above and below. Interpolation and extrapolation. Interpolation is estimating a value within the range, so between the maximum and minimum of the data points. So if you need to figure out a number that falls in between the data range, you would use interpolation. Extrapolation is estimating a value outside the data range, so less than the minimum and greater than the maximum of the data points, is called extrapolation. Okay, so define interpolation and extrapolation. We have the definitions right here at the bottom of the handout. Okay, we're now going to move into an example, the first example, using these concepts. So I'm going to ask you to flip the page. So here's our first example. Example 1, the table below shows the relationship between the price of a book in Canadian dollars compared to the price of the same book in American dollars. Place the Canadian price on the horizontal axis, so the Canadian price will be the independent variable, and the US price on the vertical axis, the US price would be the dependent variable. Plot the points and draw the line of best fit. So here we have our table of values. These are all the various books. The price in Canadian dollars is given right here, and we said that that is going to be the horizontal axis or the independent variable, so it goes first in our table of values. The dependent variable on the vertical axis is the price in US dollars, and that is on our y-axis, okay, and so that goes there as well. All right, so what I'm going to get you to do now is just take a moment, please, and I want you to plot these points on your graph, okay? Don't forget to label the graph and label the axis. And it is often helpful too to draw point protectors around your points so you can easily identify the points that were given in the data. So I'll let you pause the video right now and go ahead and graph these. Remember, these are on your x-axis or your horizontal axis, and these are on your y-axis or your vertical axis. Okay, we're back, and I have plotted the points onto the graph, and as you can see here, along the x-axis or along the horizontal axis, my independent variable, Canadian price, and I've labeled it, and in brackets, the units are dollars here, or in fact, better yet, we would write CAD dollars, Canadian dollars. Same thing with the US price here. We should have, in fact, instead of just dollars, it might be better if we labeled that US dollars. So I'm going to go ahead and change that. Okay, there we go. I've changed it to US dollars for the unit of the US price. I've also included a title for my graph, price of books, US dollars versus Canadian dollars. So just so you remember, when we do our titles, we generally put Y versus X for our titles. Okay, so the dependent versus your independent. Okay, state whether the data has a positive, negative, or no relationship. So let's go back to the first page of our notes and remind ourselves what is a positive relationship, what is a negative relationship, and so just take a moment and see if you can remember what that means: positive, negative, or no relationship. All right, just pause the video. Okay, so if it's a positive relationship, that means that the slope has to be positive, So y has to increase as x increases. Is this the case here? Well, as x goes up, y is also going up. So that means we have a positive relationship. So my answer here will be that y has a positive, or sorry, the data has a positive relationship. Okay, and just to reinforce that, y increases as x increases. Okay. The other thing that you can say is that the slope is positive. And when I mean slope, we don't have a line here, but when I do go to draw a line of best fit, the slope will in fact be positive. Okay, describe the relationship between the two variables in words. So my two variables here are the US price and my Canadian price. So what I would say is, as the Canadian book price increases, the US book price also increases. Right? So as my independent variable increases, my dependent variable also increases. That's a positive relationship. Okay, so what I'm going to do now is I have not yet drawn a line of best fit. So remember, I'm going to draw a line of best fit, and to do so, I'm going to try to go through as many points as possible and have approximately the same number of points above and below the line of best fit. So when you draw a line of best fit by hand, you do your best to follow those rules. However, there are computer programs that when you input this data, they will determine what the line of best fit is for you. And they follow a computer algorithm to determine that, a statistical algorithm that gives you their line of the best line of fit through that data. But in this course, what we're going to just try and do is we're just going to learn the basic principles and try and do it by hand, right? So I'll give you a second and try and draw your line of best fit through this data. So I'll get you to go ahead and pause it and do it. Okay, this is the line of best fit I chose to draw. It's going through as many points as possible. It's also accounting for the fact that this point right here is a little bit more distant, not as grouped together. So that causes your entire line, when you go to draw it, you should account for that it's a little separate and pull the line over. I wouldn't say that this point is so far off the rest of the points as to be considered an outlier, because it's not down there, for example, or it's not up here. It's pretty close to the other points, so it does have an effect on your line of best fit. So what we're going to do is we're going to take this line of best fit and determine the price of a book in Canadian dollars if it costs $2 US. All right, so I'm going to start on the y-axis because I have $2 US. So I'll look at my vertical axis, $2 US right there. Okay, so I end up at this point on the line of best fit. And what is the Canadian price? Well, I go down here. The Canadian price would also be $2. So the Canadian book price would be approximately $2. Right, and I use approximately because, again, the line of best fit, since we're doing it by hand, right, everyone's line of best fit is going to differ slightly, right? So I have to account for the fact that there's an approximation there. Now, is your answer in part C interpolation or extrapolation? So, and let's review. Interpolation. Did I estimate a value within the range of data, or did I estimate a value outside the range of data? So this is your range of data from here to here, and the point was over here. So if my point is over here that I had to look up, and my data is ranged from here to here, then I had to extrapolate because the point was outside the data range. So we're going to write that. Extrapolation. And that is because the value was estimated outside the data range. Next, use your line of best fit to determine the price of a book in American dollars if it costs 13 Canadian dollars. So let's go back to my graph here. I'm going to look at 13 Canadian dollars, so I'm looking on the horizontal axis, 13, and I go up right here, and I hit this point right here, and I'll go across to the US price. And so 9 is in the middle, and it's halfway between 9 and 10, so I'm going to say the US book price is approximately $9.5 US, right? So is your answer interpolation or extrapolation? Well, let's go back to the graph here. 13 Canadian dollars is right here. I go up to my line, and as you can see, the point is in between or is within the data range, right? The point that I'm estimating is within the data range. So this is interpolation. Interpolation, and that's because the value was estimated between or within the data range. Great. Okay, so one of the final things that we are going to do, which was one of the final learning expectations, was determine the equation of the line of best fit. And to do that, we're going to use a separate example. So flip the page, please. So how do we find the equation of a line of best fit? Well, we have to start by picking any 2 points on the line. We calculate the slope. Then we sub one of the points in to find the y-intercept, and we write the equation. All right. So let's take a look. This is very similar to what we have done in analytical geometry unit, but we will review it again. So let's take a look. Example 2. The graph below shows the lowest price airfares for flights from Toronto to various destinations. A line of best fit has been drawn. Determine the equation of the line of best fit algebraically. Okay, so the first thing I'm going to do is I'm going to take a look. Here's my line of best fit, and it asked me to pick any 2 points on this line of best fit. So it actually doesn't matter which 2 points I pick, because since this is a line, the slope is the same no matter which 2 points you pick. The slope is constant in a line. Okay? So I'm just going to pick 2 points, and I'm going to make my life a little easy, and I'm going to pick 2 points that lie at the intersection of grid lines, right? So for example, right here, I'll pick that point because it's right at a corner, and okay, I'll pick this point too. All right. So step 1, pick any 2 points that lie on that line. So the first point right here that I've picked is the x-coordinate is 400 and the y-coordinate is 140. The second point, the x-coordinate is 1,200 and the y-coordinate is 220. Okay, so I have my 2 points there. Step 2, calculate the slope between the 2 points. So step 2, the slope is given by this equation. These are one of the equations that you can use to find slope. Second y value minus the first y value divided by the second x value minus the first x value. So y2 in this case is 220 minus y1, which is 140, all over x2, 1,200, minus 400. Okay, performing that calculation, I get 80 over 800. And I can see that that is a fraction that I can absolutely simplify. So I can simplify that by seeing, okay, what could I divide both of these top and bottom by to reduce that down? And eventually you should get to 1 over 10. And one way to look at that is, okay, well, if I have a 0 here and a 0 here, I can cancel those two zeros. Okay, I can reduce it that way. And then I would have 8 over 80. And 8 over 80, I can divide the top and bottom by 8, and then I would get 1 over 10. Now, typically when we work in math, we generally like to use fractions, and we like to keep fractions. However, given that this is a problem-solving question, and we have units such as dollars and miles, and there is a context to this problem, since there is context and units, it is okay for me to take this fraction and write it as a decimal. However, if it was just a general math question with no units and no context, typically we would like to keep it in fraction form. Okay? So we have over here a slope of 0.10. So if I think about the equation of a line, y is equal to mx plus b, right? That's what I'm trying to find, right? The equation of a line, of this line of best fit. I now have this slope. So I have y is equal to 0.10x plus b. So I need to still find my y-intercept. And how do I find my y-intercept? Well, let's go back up here. Step 3, substitute the slope in one of the points to substitute into y equals mx plus b, and solve for b. So I have the slope there. So I'm just going to pick one of the 2 points here, and you can actually pick any point on that line. It will work, but I'm going to pick this point. And so step 3, I'm going to pick this point right here. Sub 400, 140 for x and y. Okay, so I have my statement as to what I'm substituting. And so y will be 140 is equal to the slope 0.10 times x. X is 400 plus b. And I need to solve for b. So I'm going to simplify that a little bit. 140 is equal to 0.1 times 400. Well, that's 40 plus b. I need to get b by itself, so I'm going to subtract 40 from both sides. Okay, and that gets rid of this 40 because 40 minus 40 is 0. So that becomes 0. And 140 minus 40 is just 100 is equal to b. So I have my y-intercept. And that's my y-intercept. Let me just double check on the graph. Does that make sense? I can check my work. Does 100 for my y-intercept make sense? Yeah, the line goes through, looks like the line definitely goes through 100 on the y-axis, so that definitely makes sense. So the equation of my line of best fit is y is equal to 0.10x plus 100. Now before I state my final equation, I have to look. Y, the y-axis or the vertical axis, is given in the question as f. So the y-axis is f because it represents fares. So instead of y, I will write f is equal to 0.10, and the x-axis here is given as distance, so small case d. So lowercase d plus 100, and that is the equation of my line of best, that's the equation of my line of best fit. So just looking at the lesson expectations one more time. We defined the scatter plot and understood its purpose, again given right here. We talked about what outliers were. We drew lines of best fit, and we drew lines of best fit given these right here. Goes through as many points as possible, having the approximate same numbers above and below the line. Determined whether a relationship was positive, negative, or neither. Covered right here. Define interpolation extrapolation. Well, we defined it at the bottom of the page, and we did an example on interpolation extrapolation, and determined the equation of the line of best fit is given on the second example, steps, and a step-by-step solution as well. Great. Thanks for watching. The next 2 pages are for homework. One thing that I would like to just suggest right here is if we could just right here, there's some missing words. For an experiment, some students placed measured volumes of water in a glass cylinder and found the height of water in the cylinder. Okay, so for all these questions, please get the next 2 pages for homework, and also if you could find the equations of the line of best fit. Thanks for watching.